May not be with us.
Okay, I clicked the stream button and it says it's streaming. So with that, let me just go around and, well, not go around, but thanks everybody for coming tonight to Utah Colo. Thanks very much to Vivint for hosting, providing the food and the space. Thanks for Utah Forge for just being a great community that brings people together and lets everybody know about the various meetups. And I'm AJ, your meetup host. And now we have Chris, who's gonna tell us about local AI, hardware, and harnesses. So over to you, Chris.
Thanks. And I said this before, but I'll say it one more time. I have this presentation. We do not have to respect the presentation, right? I'm very happy to go off and we can talk about what's actually interesting to you guys. Being the person that I am, I decided to get really vulnerable with you guys and show you like inside my setup, show you inside what I'm doing. This is stuff that I do as like qualifications. One really fun little thing before we get into this, at Viox we switched completely to local on-prem AI. And that ended up saving us about $87,000 per month, which was awesome because we had about $72K in cloud spend and then we had about $15K in just token spend. If you know Jepson, that you'll know why that token spend was so high. And now all of it is local, running out of either my house or Jepson's house. It's pretty cool.
Out of your house?
Out of my house, out of my cellar. So that's the first part, cost, right? It's easy to justify doing it locally when you don't have to pay for it. Obviously, like there's the cost of the actual hardware, and we end up looking at that as a front-loaded cost. We talked about this a little bit before, but one of the things that we looked at is that $72K per month was coming from 8 H100s that we were renting on GCP. That's how much it cost. One H100 costs about $15,000 used on eBay, or even the brand new ones cost about $20,000 to $30,000 right now. So you can end up buying 3 or 4 of them in like perfectly working condition for the same price as renting 8 of them for 1 month. And that's where that it starts to not make sense to just rent it if you want to have like long running, always on stuff. I said latency here because I was thinking about it, because I remember when we initially switched, we had our data center was in US West 2 and the latency wasn't bad, but the latency is a lot better when it's just on your local network. The privacy, we've been able to, I've been able to do stuff. I could show you like, no, I'm not gonna show you for right now. This allows you to work in incredibly like locked down fields, right? You don't have to worry about HIPAA, you don't have to worry about FERPA, you don't have to worry about military problems. You can consult for lots of people. You can do things you wouldn't be able to do with AI when it's on-prem, because it's never leaving, it's never going anywhere else, and that's really attractive for I would say not a majority, but many companies and organizations that are looking to get more efficient. So okay, let's get into the like meat of it. What do you need to actually like have a worthwhile setup? I put the minimum of VRAM at 24 gigs. The truth of this column, this VRAM column, is it's actually RAM plus VRAM. You don't need a 3090 or a 4090. You can do it with something smaller, but your RAM, which is your system memory, and your VRAM, which is your GPU memory, should add up to 24 to 32 gigs. And then you can start using models like I recommend Qwen 3.59B. It's really smart. It's a heavy hitter for its size. And you'll immediately see that like, no, this is an Opus 4.6. No, it's not. It's not one of the huge ones, but it's tiny. Of course it's not, right? And then you can get into bigger stuff too, right? Like I would put myself in this serious range. I have about 500 gigabytes of, actually it's about a terabyte of VRAM and about a terabyte and a half of RAM, all in a big EXO cluster in my basement. I would say 500, but that's not. There's a lot of unified memory in there. There's a DGX Spark, there's a Framework desktop, and there's a Mac where like it ends up being computed as VRAM anyway. Anyway, these are the tiers that I would say. Does anyone have any questions at this point? Anything about what they'd like, what they have, anything so far? If not, I'll just keep going.
So, how much is this costing you in power per month?
I don't know.
Do you have an estimate? Did your power bill go up to like $50 more, $300 more?
No, so I have solar, and I think I have paid $6 this year.
I know
So
the Mac Studios, when they're under load, it's like $20 a month, maybe, if it's like 24/7. Like, those things sit kind of, so.
yeah, it's if I was doing this 24/7, I'm sure that it would be more than $6, but it's like me, a couple of people that pay me monthly to use my compute, and my family, and that's it. Right, so we're at about 12-ish users. Anything else before we move on?
This is in Utah,
This is in Provo. This is on Center Street in Provo.
so 8 cents a kilowatt hour versus if you were in
Yeah.
California, you would be paying 35 cents a kilowatt hour.
Yeah,
Where did you buy your hardware?
all over the place, right? I bought the Mac Studio from Apple. I bought the DGX Spark from NVIDIA. I actually bought it from like a warehouse retailer that was selling like pre-orders for it. I got a Framework desktop. That's the Strix Halo that I have. I have Raspberry Pis that I got from, I think, just Pi Shop USA, right? It came from all over. There's an iPhone 12 that's part of this cluster too. That's just, I stopped using the iPhone and plugged it in and started running EXO on it. Anything else? Go ahead.
On the RTX 6000, do you recommend that versus just a regular A6000 because it's newer, right?
So this is where we're getting into interesting stuff, right? I like the unified memory because I get a lot more of it and I can run bigger models. And I don't care that I'm not going at 60 tokens per second. I'm only going at like 35 or 40 tokens per second. I don't really care about that. If you do care about that, if that is like critical to you, you should go with like the 6000 Pro or the A6000 because I end up looking at GPUs for these setups as just accelerators, right? Your RAM is where you load everything in and you put the important parts, the heavy load on the GPU, and it accelerates it and makes it run really quickly. If you don't have a GPU, you're not getting that same acceleration. Or if your GPU is integrated, you're not getting the same amount of acceleration. It is accelerated, just not nearly as much. The RTX 6000 Pros really fly, and the A6000s are faster.
Do you have to configure it for how to do
No.
those kind of things, or it auto?
So this is a really fun part of working with local AI is you're kind of standing on the shoulders of giants, right? AMD community has created ROCm. ROCm is really good. Vulkan, I don't know who made Vulkan, but Vulkan is like pretty universally compatible as GPU drivers that can be used for LLMs, both on the training and the inference side. And CUDA is ubiquitous. Everybody can use CUDA. And so kind of regardless of what you get, as long as it's not an Intel GPU, there's really good there's good frameworks, there's good hardware support. It's only like newer stuff or an Intel GPU that you'd have to tinker, and even that tinkering isn't all that bad because generally you're just able to hook into however the computer is using the GPU anyway. Right, that may take fiddling with your grub settings a bit, or making sure that you're on a particular kernel and a particular set of drivers, and just pinning those and not allowing them to update. But like that's about as bad as it's gotten for me. And that's on Brent. That's the Framework desktop, the AMD Strix Halo. They have a Radeon integrated GPU, and that thing is kind of it's a beast to get recognized by anything, but as soon as it's available and recognized, it hums. It's good. Okay, here's some intuition for you when you're looking at your setup and what you can host. This is a little bit more accurate than how I normally describe it, where normally full precision is FP32, right? And in FP32, 1 billion parameters is about 4 gigabytes. You do not need full precision. Pretty much the only reason I would say you should have it is if you are training the model, because that's the best precision to train in. That's one of the reasons why I have so much VRAM and RAM, is because I like to train models. It's something that I do personally and professionally. FP16 is probably the biggest that you should go if you're just looking for that inference side of things, and that's about 2 gigabytes per billion parameters, and Q8 is 1 gigabyte per billion parameters. You can go down to like a literal ternary 0.5 bit operator, or it's like 0.68 bit operator, where your model might just be megabytes. It might not even be a gigabyte big. I don't necessarily recommend that. The models lose a lot of performance when they get that small, but like sometimes that's a good thing, right? If you if you like D&D and you want it to be really creative, that's a good use case.
Can you explain what this means? So I'm guessing floating point 32,
That's right.
floating point 16,
That's right.
and what does quantization mean?
So when we talk about parameters, right, bytes per parameter, a parameter is one node within this neural network. And each of those nodes is what's called a weight. That weight is a float. And it's a float that gets applied during, that doesn't matter as much. It's just a big old float. And so you get to choose how big that float is. Do you want it to be all 32 bits, or do you want to cut it in half and save on the storage? And that's why you can understand that it would get less accurate, it would get less good when you cut it, and you keep cutting it. But similar to, like, if you want to think about this in terms of pi, right, you won't do a perfect circle because you aren't doing the entire irrational number, but you're going to get pretty close, you know?
So is there like a cliff? You know, is this something that follows like power laws where,
Yeah.
you know, there's like a definite hardcore sweet spot where you know that's the sweet spot, because after that it just tanks?
So I recommend, if you guys don't know about Unsloth, they have some excellent docs that go into this, and they figured out some like dynamic quantization. I think it's UD, Unsloth dynamic quantization, to try and get past some of this cliff. If you look at their docs, you'll, like, I'm not going to go into it because this is bothering me not being able to move my mouse the way I want. But they have a lot of it explained. I would put the cliff. The reason that I stopped at Q4KM here is that's the smallest that I would recommend that you go if you still want the model's full performance, right? You may not be hitting all of the benchmarks exactly the way that the model did when it was benchmarked, but you're going to be hitting a good 92, 93% of them. I don't really care about benchmarks. I have my own that I use at my house to get past this, but that's about as small as I would go and still consider the model working at pretty much full capacity. But yeah, that's a really good question. I have used smaller ones. I've gone down to the ternary operators, and like I said, they work for a lot of stuff, especially if your use case is like summarizing emails or data extraction or something like that. Like it's not super reliable, but it can automate a lot of tasks, and kind of figuring out what the models are good at so that you can use the appropriate model for your task is something that I think a lot of people should be optimizing for, because I think I said this last time, right? You don't need to use 4 terabytes of compute to do like an addition problem or to get some text from a PDF. That's kind of ridiculous. So let's move on. We talked a little bit about this already, so I'm gonna skip it. There are a couple of things that you need in order, so you need the hardware, and then on the hardware you need two pieces. This can all be on the same hardware, but you need an inference engine, and then you need some sort of a harness for this to work really nicely. These are good inference engines that I recommend. Olama is not on this list, but you can use it. Like, I'm not going to look down on you if you use it.
Are you sure? Because I got that impression last time.
I'm going to look down on your compute. I won't look down on you as a person.
What? Because it has MLX now.
Yeah. Isn't MLX has MLX too? You could just use MLX, right? I don't like Olama because they very blatantly just copy from community projects like Llama C++ and MLX, and it's so blatant that they literally copy like failed PRs and bugs. And that, I don't know, that bothers me, especially when you're getting business with Olama Cloud. But you can use them. They're not the worst. I put TGI and SGLang on there. I don't necessarily recommend those for the majority of use cases because they're both, what do they call that? They're not in active development anymore. They're not quite stale, but they aren't supported. They've been archived. They're good how they are though. If you're using NVIDIA, I would recommend VLLM probably regardless of what you're doing. That is literally NVIDIA's backend for all of their inference tasks, like their corporate and customer facing backend. It can handle a lot. And Llama C++ is fantastic, and I recommend it in pretty much every other scenario. If you want like a fun, I have this up here. This is my Mac Studio. This is LM Studio. Right. If you want something that has a UI, which for the Mac Studio is actually pretty good because, go figure, this has MLX too, right? And you can see that if you go into the runtimes. There it is, LM Studio MLX. Anyway,
Is that how you typically run it?
this is how I run a lot of stuff, but no.
As a server?
Oh, hold on. Just as a server, what do you mean?
I mean, like in like VS Code or something like that. Like, I don't know.
Oh, I'll show you.
Yeah. So I mean, I've done it.
So
I like all because I'm not like super engineer dude. Like,
Well,
I like
LM's
GUI, so I use LM Studio.
LM
And
Studio is
sometimes a
fantastic.
Llama.
You get all of the benefits from Llama C++ and from MLX, and you don't have to compile any of it. You don't have to do any of that. You get benefits from building it on your own because you can optimize it and you can make sure that you can put stuff partially on your GPU and be really good about offloading all of it and really pushing it. LM Studio still lets you do that, it just won't let you push it quite as far. Even if you have developer settings on and you turn off their guardrails, they like won't let you set your computer on fire.
okay, this is gonna sound stupid. Okay, Olama makes it simple, right? Like I can get started and I can run it within a matter of
Especially if you love the terminal, right? Olama is great if you just want to type Olama serve whatever.
yeah, and then use something else to be the UI.
Yeah.
Okay? Because it takes like literally seconds to get started with. When I have looked at like the readmes for Llama CPP, just right off the bat, it seems like you gotta have a PhD in data science.
No. So I know the guy that made it, and he is a physicist, and that's just how he talks. You can just brew install it, right? Like that's how simple Llama C++ is. You can just homebrew install Llama CPP, and you get it.
And maybe you'll talk about this later, but can I set the options that I need with these? I mean, I guess just what you showed there with LM Studio, that looked like it had about 50 different toggles on the screen.
Oh yeah, it's because I have developer mode on. This is the main toggle. Stop server.
No, I don't want to do that.
Boop. Now it's on. See, that's it.
But
These toggles are the fun things. This is where it becomes more art than science of like How much of it am I offloading from or to my GPU from my RAM? Am I going to try and extend my context window beyond 1 million tokens? Because you can do that. How many experts am I going to let it do? Am I going to use the same seed that it was trained in, or am I going to go off in some new random number generation, right? Like, this is stuff that you don't have to worry about, because in LM Studio,
Do they have presets?
they do. When you want to download a model, like today I was looking at Quen 3.6 because it just came out, right?
I just loaded that on my LM Studio right here.
Isn't that fantastic?
Yeah, I was like, this is sick.
It just came out, and they already have, this is Unsloth, whom I've already introduced and I love. They already have community settings and configs for each of these, and you just click the big download button and then it'll load.
But how do I know which one? I mean, there was a list of at least 20, 30
You
there?
pick Unsloth and then you just.
You pick Unsloth, yeah. Or
Or MLX.
Wait, where?
look at
where
this.
does it say unsloth?
They have staff models. Oh, so see, like Quen 3.5 from the LM Studio community,
Uh-huh.
that's a safe one to go. Like, people are not doing malicious models, it's just safe that I know that it performs nicely.
Well, no, I mean, like, when I look at this list, I have no idea which one I would pick or why.
You would pick this one, you would pick Unsloth right
Okay.
here.
Okay, oh, I see now unsloth there, okay.
And then you have download options, and this, here, let me do a different one. Let's look at Kimi K 2.5.
To be fair, I assumed you just did the ones with the most hearts, because that's what Unsloth is.
You can do that, yeah.
I don't trust
2.5.
that metric because
So look at
the person
this.
is smart, but people are stupid. I learned this from my friend Kay.
So this is another thing that makes LM Studio attractive. They load this data from Hugging Face, which is kind of funny. They literally make an API call to Hugging Face for hardware estimation. But we can see if I try to load the Q3KM, it is likely too large and they will get mad at me. There's this middle ground where it might fit if this is the only thing running on the PC. This is where I like to live.
You can just sort of,
But then there's all of these where you can kind of game it. Right? This is helpful for answering those questions before you have an intuition of what this is. But the intuition isn't all that hard, right? GGUF, Georgi Gerganov is the guy who made Llama C++. This is the Georgi Gerganov unified format. That's what that stands for. That just means that it will work in anything that uses Llama C++ under the hood. It will also work with transformers from Hugging Face because they created a loading structure that works with it. It will also work with VLLM for the same reason. It will not work with MLX, but there are MLX versions of the models too, and you can search for those if you're on a Mac and want to. Likely too large, but
yeah, the nice thing, sorry,
oh, go ahead, dude.
I was gonna say, in that best match, like under the search bar where the best match is, there's a box that says only include staff picks that can fit on this device. And if you wanted to be like super safe on like what models to install or to use, just check that. And then it'll have all the ones that have a check mark next to it. And it'll fit on your device because it knows what you're on. So.
Do we have more questions? Because this is like a deep subject that I swear not very many people have intuition built for, and I'm happy to lend you whatever I have.
I'm curious to the extent you want Llama CPP for exploration.
For exploration?
Or I mean, that's what it says, right? Like production versus exploration.
Oh, so this is a. I wrote that because VLLM has incredible concurrency scaling. They do a thing called hot swapping for tokens with the KV cache. And so if you are building for a team of more than like 8 people, probably you want VLLM, because then you can fit a lot more concurrent users on your same inference engine. Llama C++ does have concurrency, but it drops off pretty quick. So that's why I wrote that. That doesn't mean that Llama C++ is not something you should use in a professional or production scenario. It just depends on how many users you're expecting to serve concurrently. Go ahead.
We talked about this elsewhere, but my experience has also been that VLLMs versus Llama CPP specifically, from release to release, the flags behave wildly differently and/or don't.
Oh,
work.
yeah.
So like, once you've got like Llama CPP working, you can usually change it over time. So it's better for exploration than VLLM, which is like, does this flag work in this version?
Oh,
I don't know.
you gotta pin really hard with VLLM. Like, just, yeah, we're never updating this once it's working until we have to. Which,
Maybe a scientist.
yeah. Yeah. Yeah.
Yeah.
Okay, so we're slide 9 out of 29. I'm just gonna start going because we've already hit a couple of these. This is important. Your KV cache. So we talked about intuition with your actual model size. Now I want to talk about intuition with your data. That also has to go through this and also has to be cached and saved and also does everything there. I would say 128,000 tokens. This is, I think the actual number is 131,072. That number takes about 60 to 64 gigabytes of space. So when you're estimating your context window size that you can use for your models, that's where I would start. Is 128K is about 64 gigs. If you don't have 64 gigs, go less. If you have 64 gigs just or more, just do that. If you have tons more, just do more, right? That's like a really good landmark to sit on. And this is helpful because so many things require grounding, whether that's through web search or RAG or some type of outside information being processed. And you got to be careful with that because context raw, it's a real thing. So after you've got your hardware set up and you have your inference engine up and you have an endpoint that's ready to be hit, this is it. You build agent workflows. Now, I floated this last time, but I'm gonna plug it again here. We're not gonna do symphonic auto research. We're gonna do AI Makerspace. If you wanna see a bunch of examples of this, this is a repo that I made based on an AI engineering cohort on Maven, where I did everything self-hosted, I did everything local, and it's all here. So if you want to see agentic RAG from scratch, it's here. You can use Marimo to like view it, but it is just a Python file and you can just read it, right? If you want to see deep agents, if you want to see knowledge graphs, if you want to see advanced retrieval, it's all here. So when you're looking at like what is, so I have an idea for a harness, but how do I do it? This can give you a reference file that you can give to an LLM to give you something to start with, right? I think that that's the easiest way to give you a good resource. So now let's talk about what is the difference between an agent workflow and an agent cycle. These are two types of harnesses that people use and they often get interchanged. You could think of workflows and cycles kind of like data structures, that they aren't, they're just things, and you can combine them and you can put them inside each other and you can hook them up to each other. You can make a linked list rather than trying to look at it from some sort of product standpoint. The main key difference though is just with a workflow, you know what the steps are always in this order. That's it. If you know what the steps are, they're always in this order. You make a workflow, and then you don't allow the agent to decide when it goes to what step because it will screw it up. The cycle is when you don't necessarily know what all the steps are, or maybe there's a variable number of steps, or they happen in different orders. That's when you want cycles, so that you just define what you need out of each step, and then you can check if that happens, and if it doesn't happen, you go again. Or you do logic manipulation, or you do something to correct it.
To me, that sounds like the difference between imperative and declarative.
Absolutely, yes. Yeah. we talked about this. Yeah, this is pretty much it, where you have your cycle or your workflow that calls tools. Your workflows can also call tools. The point is that it is an LLM doing it, right? In the workflow, you can force the LLM to call a particular tool, but you don't force the LLM to call a tool with particular arguments, right? It will still define what the arguments are, even if that tool is an immutable part of your workflow process.
So with a workflow, is it basically, it's still like doing the Ralph loop, but it's like, say you're done when you're done, and then it feeds it the next prompt?
No, that'd be more of a cycle, right? Ralph loops are cycles, the Ralph Wiggum loops.
But what I mean is like with a workflow,
I'll give you an example. A workflow is a DAG, right? A workflow is, hey, git commit, you say what the message is, and then git push origin branch that I'm working on. That's it. Like, don't do these out of order. Don't screw with anything. Just give me the commit message and then push.
but it has to know that it's completed the task somehow, right? That's what I'm saying, like, doesn't it, like, if it fails the task, won't it still
The
try
agent
again?
doesn't have to know. The program has to know, right? And you can just take
Okay.
a signal from GitHub that you got a 200 when you tried to push, right? You actually completed the push, and then that can end the workflow. Does that make sense? You don't have to get the okay from the agent for a workflow to end. And in fact, I would recommend that you don't. The agent should not be involved in deciding when the steps complete or end in a workflow.
So with a workflow, generally, each step should be programmatically, you should be able to determine that the step is completed successfully without the LLM.
Right,
And then you run the LLM again if it failed.
if it failed. And that's one of the reasons, or you can do a fun thing where you have like a try except. That I like the Git workflow as a paradigm to think of it in, because your commit message is going to depend on what you did, and you need an LLM to be able to summarize that. Or you don't need it, but like you understand that it's variable, right? That commit message could be any string, and if it fails on the git commit, I may want to start an agent cycle to figure out what in the world is going on, because you shouldn't ever fail in a git commit. Does that make sense? So like that's what I mean about pairing these. You don't want to just do a workflow unless you know that like there's no reason for things to fail and you would want to kick something off if they do. There's a really great library called Kitaru that I'm gonna introduce to you guys too. Kitaru. This is from my friends over at ZenML. ZenML.io Kitaru. This is fantastic for both workflows and cycles, because they're doing essentially ML ops for agents, because that's what they're good at. ML ops for the ZenML platform anyway. They're good at making it very easy for data scientists to throw comprehensible things over the wall to ops. And they're doing that with agents now too. I strong recommend if you want a lot of the same, I'm going to say assuredness, a lot of the same reliability that you get out of just writing regular code for writing agentic workflows, for writing agent cycles. This, for example, will give you the ability to, hey, it just says it right there. Your long-running agent crashed at step 7. Qatar replays from step 7, not from scratch. Because then you don't have to regenerate any of the stuff from before. So if you fail at the git push after you did your git commit, you can be sure that the git commit will stay the same message, and it's not going to all of a sudden hallucinate on the second round through. Does that make sense?
So this is capturing like a request or context or something?
Artifacts. They have an artifact store that runs alongside things. So when steps finish, they pass artifacts to the store to save them between jobs.
So I could reboot my computer and or
Yeah.
server and then resume step 7 3 weeks later
Yeah,
on a different model provider with the
Which-
same model.
that is what I use. Or different provider, same model, different provider, different model. You can, all of that. I really like them, and I get frustrated seeing people run into problems that are already solved. So just use them if you want, right? MCPs. I figure we have to talk about these. These are at this point outdated and redundant, but they have a lot of industry adoption. So you shouldn't feel bad about using them or wanting to use them. There is a universal tool calling protocol, which is better in like every single sense, including just straight up model performance. I recommend that, but there hasn't been like a whole ton of industry-wide adoption because people really like Anthropic. So that will come after Anthropic integrates it officially, right?
Well, okay. When I've run stuff locally, and I've seen this in forum posts, it seems like some models are trained for tool calls in different ways. Like some of them have like an XML tag, and then others have like an all caps thing.
Yeah.
And then it seems like the tools should just be like, oh, it's a tool call that it wants to do, so I'll just implement the 3 different text formats, but then they don't, and they return an error instead.
Yeah, so there's more like several hundred different text formats, because the logic behind tool calls is the developers were like, hey, we need to figure out a set of characters that appear in a certain order that is not used accidentally ever by a person. So you can do malicious tool call injections by just giving a tool call string to a model, and it, like, most people are filtering those out, but the people that don't will get pwned by you, right? Because it's just a string. So XML tags, some of them are all caps. Some of them use ZWX because that like never appears as just a token. That's like the beginning and the end tag of the tool call. The point though is that there's like an infinite number of ways that you can do tool calls, and not everybody is conforming the way that I think that they should, but then other people are also not keeping track of all of them.
So are models being trained on the wrong way to do tool calls? Because I thought the whole thing with the tools, like if a model is listed as or tagged as
Tool calling,
tools,
yeah.
then I had assumed that it had been like given training data for some specific format, and that's why it would get it wrong.
Well, no, it also got trained on playing chess, and they're not good at that either, right? This just refers to how much they were trained, and you can generally assume if it has a little tool tag, it was trained a lot on them, and so it should get them right, but it can and does get them wrong. Even big models, like Kimi K2.5, I've never gotten that one to be able to do tool calling consistently without me creating some sort of like tool call healing middleware hooks around the model to make it act, like just fix it, because it's going to screw it up sometimes, and I know how it's going to screw it up, you know?
So MCP versus UTC,
UTP.
UTP, what's the difference?
Here.
And by the way,
Let's
anybody,
look
feel
it
free
up.
to tell me to shut up. I'm going to ask lots of questions because you're
Universal
not asking
tool
questions. I'm
calling
confused. Go for it.
UTCP.
And what makes this better? Like, how can you say the other one is outdated when it's the only one that anybody in this room knows about?
Because it was outdated before it was published because of this. It's code mode. Instead of doing tool calls through JSON and very easy to mess up many token things, it does tool calls through bash commands.
That makes sense, yes.
Yeah. Does that
I agree with
immediately
you.
go, this is better? It is.
Yeah, because that's what I was thinking is like, why are they making this weird tool call syntax when there's already syntax that it knows and it's been trained on that works all the time?
It's because of the never-ending argument between data scientists and engineers of like, well, we want this to be unique and natural language, but it has to be consistent and not appear when people are just typing, right? Like, and they get mad at each other. And so this was some machine learning engineers who exist at that, whatever you call that, crossroads, that figured out a better way. And I don't feel like there's a whole lot of argument about why it's better or that it's better. It's just people don't know about this as much because it doesn't have like huge marketing behind it.
Is this what you're using?
Oh yeah.
every place you can.
every place I can. Yeah.
Can you scroll to an example of what it looks like?
Oh, sure.
Yeah, with everything you talk about, I would love it if you would give like a
And give a
hardcore
list of
example.
Links at the end to drop in the like code or.
Sure, yeah, I'll put it in the Colo channel. Let's see, do they have? They've gotta have something on code mode. Dare we watch some YouTube?
Do you know what it looks like syntactically, like the wire format?
Yeah, let's hit that.
Because I'm guessing what it is it's some sort of tool call marker, and then it's just POSIX style argument passing, flag passing. Is that?
Or ignorantly is the example of you showed us earlier, that directory have an example of this?
That directory doesn't have an example of code mode. They have this is so ironic. They have an MCP server for showing how you can do code mode universally. The tag ends up looking just, I don't remember. They have, I think, just a double slash and then bash commands for the tool call. I don't remember off the top of my head though. I can show you. I mean, if you use Claude Code, this is how you put it in. If you use LM Studio, this is how you put it into your mcp.json. If you use OpenCode, this is how you put it in to your mcp.json or your opencode.json, right? It's not that big of a deal beyond just it's way better for models. They mess up on it way less, even smaller models. Like I'm doing a thing right now where I have Quen 3.59b running in a browser, and it can do tool calls in the browser using code mode way more consistently than using any sort of MCP or regular tool calling. This is it though. This is your usage. So that's what that wire is. Call template type, MCP, CLI file, HTTP, and then it just writes the bash command after.
It's also way nicer on your context.
Yeah. You don't have individual curly braces taking up your token count.
It's nasty. Is there like a repo for people using the universal tool protocol? Like say, hey, somebody implemented stuff.
Yeah, that one I was just showing.
So that whole GitHub has basically people come in and put stuff in there.
Yeah.
Nice.
Yeah, there's a community. It's like I said, it's not very big, and it's pretty much only people that know about it. Hopefully it gets bigger now, you know. Let's keep going. Okay, so again, being the person that I am, I wanted to show you something that I was currently working on, and it's not finished, but it's done enough for this. Where Andre Carpathy posted about an LLM wiki, and I figured that was like something that is like a good start to improve upon. Basically just a little library of Alexandria of stuff that you care about that is all linked together. This is the architecture. We don't have to go into that all that much. I picked Obsidian as storage. Obsidian is nothing. You don't have to use it. It's like it's nothing. It gives you a nice little UI where you can see the cute little bubbles pop up in a nice little network. But the reason I picked it is because I thought that this double bracket links for the navigable graph was really, really nice. And I got an LSP. It's Thai using those double brackets for an LLM that will navigate this, or a retrieval engine that will navigate it. Ooh. This shows a broken link in my presenter notes, but it's not broken. These are the whatever docs. This is it. That's not very interesting to look at. So I made this cute little ASCII cinema demo for us. So we can see like all the models that are available. We can see how many chunks were in there when I was running this in the index. Those are 8 documents that were each split into 8 chunks. I like to do semantic chunking for my retrieval, which is annoying because it's not semantic, but it works really nicely. And so here's running a query for how does MCP integrate with RAG. It uses Qwen3 embedding 4 billion parameter, which it's 2560 dimensions, and we can see like it is pretty good for what it's actually returning. And then here's one with web search where I keyed it up so that if it has to go and search the web, it will immediately ingest whatever it gets from the web and cache it so that I never have to make those calls again. It just progressively gets bigger.
When you cache it, are you caching that in Obsidian or somewhere else?
I cache it for the same session because I didn't want, I mean, long running cache has tons of problems, but it writes an MD file the same way that it would for ingesting like a PDF or a website or something else. So you have all these MD files kind of working as memory. So I'll give you a little bit of a tour of it in a second, so you can see what it looks like on the inside. And yeah, this is me showing that, oh yeah,
Step 5 says it caches in Obsidian.
yeah. Obsidian is,
It's like a UI for.
it's not helpful for this, you know, that's just something that I picked. So it does cache in there, but it's not, that cache isn't long running and it doesn't really matter because it's not helpful by itself. Anyway.
This also works really good in OpenClaw.
Oh, I believe that.
What worked really good in OpenClaw?
OpenClaw and Obsidian is sound brain.
So, I guess, this is something that models generally don't know about unless they search the web. It's a really niche topic, but it's in my whatever you want to call this, my wiki. And so I'm gonna let it do the retrieval and then talk to me. And we'll get a public demonstration of how fast this goes, which becomes a little bit more fun to watch it go right here too, where we're getting some good concurrency there. It won't start on the prompt that it finished until it does both of these. This is a quirk of any parallelism that you have in LM Studio. But as soon as this is done, then we can go back. And it doesn't expand the thinking in this web UI, but yeah, this is nice. So see how many tokens this used?
No.
If you,
Where's that?
oh, it's one paragraph,
Oh.
right? If you go try this right now on any LLM that you care about, it will use several thousand to look for it, to go and figure out what the user might be looking for, all of that. I get to bypass it by just giving it a retrieval structure that both conforms to what it is expecting as context and what I am expecting as an output. This is incredible for anybody that's looking to lower their token spend, for anybody that's looking to get faster responses, right? One of the things that I've tested quite a bit with GLM5 and now GLM 5.1 is even though they run a lot slower on my cluster than Opus 4.6, I usually end up getting answers a lot faster because I don't have to deal with a 5-hour window, right? Even at 200x, the Max Pro plan, I don't have to deal with that 5-hour window. And so I can just leave it running all day, all night, and I can be confident that every single time it's retrieving information about whatever I care about. Like, here's this. What about causal attention? I'm gonna try to not spell it wrong, but I bet even if I did, it would work. That ends up being much more of a time saver than just running it on like enterprise servers, even though those do go a lot faster than my local setup. And I get to watch the context window of this. Like this is funny. This right here, this context. This so this gives the full breakdown and everything, but one of my favorite things is watching the, oh, I don't know where it is. Oh, here it is. Total cost, right? I love watching it go up to like 1.5 million and 2 million tokens and having that stay at 0. That really rocks. Anyway, do we have any questions about this before I kind of show you what that looks like, how you would be able to replicate it, that type of thing? Say. I'll come back over here then.
What are like your favorite models to run? Like, you know, because like you're talking about like the 5-hour window of running Opus, you know, 4.6 or 4.7 now. I mean, the ability to think and process seems to be a lot higher than most local models. I mean, is there anything that you find to be competitive, or is there anything that you anticipate like?
This is a really hard and loaded question, and that's why I'm answering it by going over here. This is my family's Open Web UI instance, so we can see, right, that Mac is borrowing compute from other devices. That's how it's able to run so much, and that's why I have like GLM 5, GLM 5.1. That GLM 5.1 is running on like 780 gigs of VRAM.
Yeah, I want to know how you do that.
EXO.
Excellent.
EXO. Run Frontier AI locally. Yeah, they're also a Chinese band that is pretty cool. Connects all your devices into an AI cluster. This is basically Kubernetes for models.
So, like I've got some R620s with lots and lots of RAM, but, you know, no GPU. And I've got a Mac Studio and some other Macs. I could install this on each of them, and then how many hours of configuration is it to get it to work?
Oh, that's a good question. For me, it took probably about 2 or 3 weeks to get it working, and then another several months of tweaking to get it nice. But I was doing it before they partnered with Apple for their freaking day 0 RDMA support. Apple is fully supported here. There's like no configuration for Apple devices. It's if you want to mix them that configuration happens. Or if you want to do devices like the DGX Spark that have hardware that's like not broadly supported, including even by the manufacturer.
So where was your iPhone 12 on that list of devices?
My iPhone 12?
Yeah. Did you say
Ooh.
you had an iPhone 12?
Yeah, it's
Wait,
so that was a list of models, right? These are not
Oh,
the devices
oh,
that it's
oh,
running on.
Right.
So you can see here like Gemma 431B is the one that I have just dedicated to the framework desktop. But these are the models that I have right now. They change, I'm gonna say sort of frequently, but especially the embedding models, I haven't changed these in multiple years at this point. I expect I'm gonna have Nemotron for a long time. I'm actually considering getting rid of GPT-OS S120B because of it. The main ones are more model families that like I just increment on the GLM models, I just increment on the Minimax models, right? Does that answer your question?
Yeah. So
Are there any that you don't see here that you're surprised by?
No. I mean, I guess I'm just
Just curious.
yeah. I mean, because you know, I seem to find the difference between you know the frontier cloud models and like just you know putting out responses and what you get versus what you can run locally. But you know, there's the huge advantage of being able to run it full time and all that. And of course, you know,
Well, and that's really the thing, right? If you don't know what you want, use a frontier model, right? It's going to be able to make a lot more of that jump to where your headspace is and your lack of communication skills are. If you do know what you want and you're opinionated about it, you can outperform frontier models pretty easily with local models, even like very small dumb ones. There's a reason why every single bank is calling in consultants right now saying, hey, we tried to use AMP code for data extraction from our PDF, our massive PDF library. All of them are doing it right now. And it's because the frontier models are great at general tasks and filling in those gaps for you. And they're not great when it's like, oh man, we're going to get sued if we don't have 100% accuracy on this data extraction. And that's where building your own and building an agent harness around your specific well-scoped task really gives you performance.
yeah, like, I guess just like when I have my, you know, local stuff running, and when I run a local model, like, I seem to have some of the tool calling issues, you know, and instead of having to put all this stuff in, I just get better performance out of like those cloud models, so
Yeah.
it's not like, so I guess that's what I guess I'm
Have you
saying
considered
specifically.
asking the cloud models to make the performance of your local models better?
Yeah,
Like you could.
yeah, I do, yeah, I
Okay.
have them optimized and stuff, so.
Well,
I mean,
not
this
like
is
that. I
curious,
mean like token healing for the tool calling, or like
Yeah.
middleware and hooks to really help it so that you don't have to deal with recalling it a bunch of times if it messes up, right? And again, like I use cloud models. This is not an anti-cloud meeting, but this is like
I mean, it is. It's literally.
sure, okay,
That is kind of the meetup.
AI.
That is kind of the meetup, is like
Cool.
you're your own client.
cool, yeah. Build your own cloud and then access your own cloud, right?
So that's what you would say then, is like you use these models and then you do like self-healing because you find that, I mean, that's really what you envision that those cloud models are really doing, right? Is
That's what they employ thousands of engineers to get ahead of those problems and make sure that when you make an API call, they've already built the exact infrastructure that I'm showing you. To like they have a knowledge base so that it can do RAG in the background and not tell you that it's doing RAG, because they don't. There's bad marketing if a customer sees too many tool calls.
Yeah.
There's also they don't want it to take too long. So there's like all this stuff. I've consulted with some of these companies, and some of them are like actual customers of Viox, and like seeing behind the curtains, this is not different. It's just I'm one dude and not 1,000 people, you know. And so you will get benefits from using tools like Claude Code. You will get it from anti-gravity. You'll get it especially in places where those companies are very good, right? Like I think there's some data showing that anti-gravity is especially good at Java, because it has tons of Java training data, which
Yeah.
is weird. You would expect it to be better at Golang, but I think Claude is actually better at Golang because of what it trains on, right?
Claude seems to be pretty good at Go. And Grok was really, really good with Go before I was using Claude. I only switched to Claude because of the harness.
Yeah.
And being, you know, like actually agentic.
Well, and so you can build a harness with Kataru, you can build a harness with deep agents. If you want to take the lessons of the Claude Code leak and you want to ask Claude to build your own harness so you don't have to pay $20 a month anymore for it.
200.
$200 a month, okay. If you
I mean, like,
better.
that only lasts 3 days now, since they reduced the.
This
since
is
they,
the right meetup for you.
Yeah, you're organizing it, right? Is that why you organized it? I don't want to pay $200 a month for this anymore.
I mean, like in general, like broad strokes, me knowing, cause I'm an old guy, right? Like I came from the days when it, like having to do sudo rc service Apache restart was not considered like mind-boggling complicated, you could never do it on your own. Whereas, you know, AWS marketed it as like, if you're not paying us for doing hundreds of lambdas and thousands of dollars per month for what can be done on a $5 VPS, like just don't try it, it's too hard, right? So
Yeah.
like I come from the day when Like, we didn't consider restarting Apache or having to open its like XML quasi config file and add a line. Like, we didn't consider that earth shattering back in those days. And yeah, that translates to today where like everything's so expensive, everything's so complicated. Nobody knows how to do anything. Nobody knows how to like write code on a computer and get it live without like 16 different SaaS products.
Yeah.
So, yeah, like for me, I definitely want to be able to use AI locally and not have. I want to peek behind the curtain for sure. But
So I'm gonna put this in the Slack channel then. This is the original Carpathy prompt for building that LLM wiki. I'll just give this to you. It's also just here, right? This is the get gist. If you want to build that yourself, but also you can just build it. You don't need an LLM to build it for you, right?
I don't know how to code anymore. I've been using Claude for the last
Great.
4 weeks.
Well
I don't
then,
remember what code is.
give this to Claude. It'll do great.
But I'm really interested in knowing what's the anatomy of, like, I'm talking like wire protocol stuff, you know, like there's text that goes in, there's text that comes back, there's text in the middle, and there's either HTTP or a TCP variant that's going on in between. That is something I'd really, really like to know. It's like, what's the anatomy of
shared a
this
link.
as you step it through?
You shared a link about this on, right, for Claude Code?
Nate did.
Nate Hearns. You're in that Discord,
Maybe.
right? The
What link are you talking about?
there's in Catalyst. There's a link somebody shared for like stepping through Claude Code. What happens when you send
yes,
a prompt?
I did that, yeah.
Yeah. Okay. So it's there. It's visual. You can see exactly what you're looking for, right? What connection is made, what is sent to that connection, what steps happen. There's some weird stuff in there, like one of the things that Anthropic found is if they give Claude like time to quote unquote dream in the back end, which that's not an anthropomorphization. That's actually like a technical term back from GANs, like the generative adversarial networks. But they let Claude do adversarial generation for a second in the background, and they found that makes it give better answers. So don't focus. No. It's generating intermediary tokens before it even starts sending you intermediary tokens that it calls reasoning. So it does reasoning, and then it reasons for you, and then it types, right? So this is just something that I think that is happening just to kind of help you be more comfortable waiting longer for a response from a UX perspective.
I do want to answer his question a little bit dissatisfactorily though,
Oh, okay.
in that there is no wire protocol. That's completely separate from all of it's just HTTP for most things, but like even when it isn't, it's just
But
plain
there's-
text.
It's strings.
But
It's
there's
just
a
literally-
sequence of events, right? Like there's a sequence of events. Like I type in text and I hit enter.
Mhm.
And at that point, my text is doctored in some way.
Maybe.
There's probably some
can
sort
show
of
you that.
semantic search that happens, and then like a memory is
No,
recalled
no,
and
no.
inserted as context in front. Then that's given to the LLM.
No, this is what happens first. Tick token. This is OpenAI's tokenizer. It's byte pair encoding. It's all here, right? The reason they use it is because this is highly optimized and very fast, even though byte pair encoding is not the best tokenization. So this happens, this translates your text into a vector, and then it goes straight into a model. There's no semanticity, there's no embedding layer for transformer models. If you're coming from LSTMs
No,
and
when I
previous.
hit enter,
Yeah.
it doesn't go straight into a model. There's a tool that takes my text,
Oh, okay, yeah.
right?
The harness.
Right, the harness is
Maybe.
taking, there is some sort of tooling that takes my text, most likely doctors it in some way. Then after the doctoring, tokenization happens.
Also
Yes.
maybe.
Then maybe some more doctoring happens. and maybe some more tokenization. Then it goes to an HTTP call to a model. And then,
Oh,
and
no,
then even with
this
that, there's
Tokenizers are right at the beginning of the model, right? There's no past,
I
it,
mean, AJ is more just like, how do you write an agent harness? Like, what's the structure of an agent harness? This is what I'm guessing, like,
So-
so cloud code versus open code. They take my prompt, I'm gonna pre-inject my, like, harness wrapper prompt.
because I think of the model as like the very last step. Like that's where my world ends and your world begins, right?
About writing her own harness was really exciting.
sort of, cause like
I've got this tool.
Like when I send a message to Anthropic or OpenAI, it's not tokenized, it's text.
Build up shell commands
Yeah.
for you, but anyway, it's.
So, I mean, like from my perspective, all of the magic is happening before it goes to the model. And then the model is its own magic.
so
The tool calling.
usually they don't do any doctoring of your text before it goes in. The only reason that,
But what
like,
about
you
the
would
RAG
trip
and all
off
that?
their, middleware. Oh, that happens after.
Just like, this is
So
What do you mean RAG happens after?
RAG happens after the initial middleware call, right? When you send your text, it hits the middleware.
But that's not the model, that's their software stack.
Right, that's their software stack.
Right.
Are you not talking about their software stack?
No, when I say model, I'm talking about like, I don't exactly know what the model is, but I think
The
the
weights?
model is being, like something's tokenized, it's given to this model thing, it crunches numbers, it gives tokens back,
You
and
could
then
also do it in.
and then it goes through
Where's the-
those middleware stacks again. Like, there's local middleware stacks, and there's server-side middleware stacks, and ideally, if you're doing what you're doing, you're in control of all those stacks.
Right, so when, I can tell you from like the perspective of like building these services, you don't do a whole lot of middleware anything beyond just like filtering out, and this is like regex filtering for like strings of numbers, like long strings. If it's more than 3 digits, you will just regex and split it into 3 digits, and then you just send it to the inference engine. And most models, like if you go on Hugging Face, I can probably show you this.
But like RAG is happening, and that like, okay, so for example, if my prompt on the outside,
Well, we're before the tokenizer here, right? The RAG happens right at this stage after you get that middleware doing the regex that splits it into the dimensions that they want, and maybe it will change like some things. Usually, like they'll often have mappings for words, like these words, for example, liberty will get mapped to freedom because freedom is in the tokenizer vocabulary, and liberty is not. And they're functionally the same for whatever the model's purposes are going to be. Does that make sense?
okay, that's good.
So
information.
that's the regex before it happens, and then you have this RAG step. That RAG step it varies a lot because retrieval is difficult. I think the industry standard right now is query augmentation. So they take your text, they don't doctor it, they just embed it really quick with usually like an ADA model. They'll embed that text, you get a vector, you do cosine similarity, and then that's where fun stuff happens. Because the cosine similarity right now, they'll usually take another model and generate more versions of your same query. So then you get a bigger kind of shotgun blast for that latent space. You get a chunk, but that chunk usually from smart people doing retrieval is not a chunk of text. That's like a title of a document, and then it retrieves the whole document based on the title being the closest to whatever you're retrieving. And a lot of the time they'll change, like if you ask a question like where should I go on vacation, they'll change it to like common vacation destinations. And OpenAI's been doing, like, that's where their AdSense comes in, is like instead of common vacation destinations, it's like common vacation destinations that Delta has paid us to put in here, right? Like that sort of thing. And that's where you get that RAG retrieval, and then that just gets fed in next to your user query in their system prompt. And that system prompt, after the regex and everything, that gets tokenized because that's already formatted and it's good. But they don't change your prompt unless they have to.
Well, okay, but let me put this a different way. Okay, if I say, write me a Go stack with my preferred HTTP middleware that is gonna solve ping pong. And I've got some skills locally and some other stuff, like, my ideal hope would be, it'd be like, okay, go middleware memory, boom, we're gonna pull that in. Go use modern Go skill, we're gonna pull that in. And I can tell it's not happening that way right now, or at least not the way that I would expect, it's not very accurate. But like, I would expect that, like, when I do a query, it would say, okay, what are things related to this query that this person's gonna want? And to some degree that's happening with like memories, right?
Yeah.
I think memories are done that way, but
Sort of.
skills are not unless the LLM asks for the skill. But somehow it has a list of skills, so it knows if it should ask
Yeah.
to load a skill. You know, so there's a bunch of that stuff
You
happening
know, the
too.
open code source code is just on GitHub,
Well-
like you can read that harness.
Also, you have developer logs in places like LM Studio or Llama C++, where you can see
Okay,
like,
yeah, this would be.
hey, this is literally what I got, and it's not letting me scroll right now. I don't know why, but
the PyKVM or whatever, it's catching the wrong signal.
yeah, it's catching the wrong signal. But you can see like there's a list, for example, of models. This is returning from a GET request. And if I send a request, like if I go in here and just do a new chat with, which one's already loaded?
So
2.7.
to the point of like open code's open source, and I mean, Claude was open source even before the leak. I mean, all you have to do is just run a pretty fire on it and then put it through an LLM to then map the function names properly or whatever. But like, reading a wire format is very, very simple. Reading through hundreds of files of code is very, very complex.
Yeah.
Shoot, I missed the actual, you can see the JSON in the logs of what it actually did, and now you can see like, what is it doing to process that prompt? And Llama C++ has really good, very clear logs, and then you see what did it send back. You have your usage, you have your stats, you have content is broken into content and reasoning content under the role assistant, as opposed to user or system or tool call, right?
Right. Yeah, so that seems to be something that's common among all of the models?
All the inference engines.
Inference engines. Okay, so maybe.
Because this model's not doing that. That's Llama C++ in LM Studio doing this.
So, how does the role? I guess this is something where I'm super ignorant. Well, all of this stuff is, but like, so inference engine. What is the inference engine versus what is the? When we say model, do we mean weights or do we mean inference engine?
We mean weights plus tokenizer is a model.
Weights plus tokenizer
Yep.
is a model. So what is the software that runs? What is that called?
The inference engine.
The inference engine. So there can be different inference engines that run the various models.
Ollama is an inference engine. Llama C++ is an inference engine.
Are they the same algorithm or are they different algorithms?
Those two are the same because Ollama copies from Llama C++, but Llama C++ is a different software than VLLM, for example. Algorithm is model. Model is algorithm.
So I was thinking
Inference engine is not
algorithm is how
algorithm.
you traverse the model, like how you analyze the weights to determine.
The model contains all of its own information for what its algorithm of traversal is, whether that's mixture of experts, whether it is fully connected, dense model, or if it is a sparse model. And a lot of the time they'll have differences between layers. So they contain that in a config that the inference engine reads to traverse the model.
So inference engine has to get updated every time model has new algorithmic.
And that's why it takes a second for something like Ollama or Llama C++ to get support, unless the lab that's releasing the model has given them early access to like the config of what are the layers of this
So what
model.
are these labs running? Because I would have thought they'd be running Llama CPP too.
Some of them are. Let me
Okay.
give this to you.
And again, if I'm taking over, like somebody cut me off. I don't
No, we
wanna,
like it.
I don't wanna deprive anybody of their reason
I'll
for being
cut
here.
you off if I want
I'm
to.
keeping your food.
I can't wait for the YouTube comments.
Yeah, well, I'm gonna have to upload this to YouTube separately because, there's all sorts of stuff going wrong. Like, the screen is flickering here as if it's not syncing with the, like, you can kind of see the flicker on the TV if you look very carefully,
So
but on my computer, it's super bad.
I apologize that this is a notebook and not something with a bit more fidelity, but this is from my book. This is chapter 9, where I recreated Llama 3 completely from just like I imported as few things as possible for this, and the vast majority of it is done by Torch. And we have some transformers and some sentence piece, but like going through this, we started with just these are the functions that you need for like getting batches for training and actually processing your data set, and what's the prompt that you're going to use. You have to tokenize it beforehand and just kind of prep end it to whatever you're putting through it, right? This is how you get your loss. This is how you compare what the model outputs to what was expected. You know, this is how you do generation. I even put in some stuff about where is it?
So this is an inference engine right here?
This right here, yeah. Torch.inference mode. This is an inference engine, this generate function. So you can see, right, there's only one spot that actually uses the model, and that's this line, and it's only to get the logits. The logits are what come out of the final hidden layer of the model. Once you have those logits, you have a vector that you need to get back into a language that your user can understand. And so you go through all of these steps of, we're doing top K sampling, we're doing last time step logits, we're comparing it to what was done before, we're doing a softmax over those probabilities to get the actual English token that is the most probable from the model.
So how does that work with code where you often have weird abbreviations?
Dude, people write books about this
Okay.
because it's a big subject,
Like
right?
you, for example.
Like me, for example. But for that, I would specifically recommend Thomas Wolfe from Hugging Face wrote a book called Natural Language Processing with Transformers. They have a whole appendix B of how did we train GPT-2 to do code better, right? Because code is syntactically different from natural speech, and so you have to process it differently, and then you have to get your probabilities a little bit differently. But you can't change the model. The model and its actual architecture is a little bit immutable once you've decided on it. So how do you get creative with how you present stuff to the model during training in a way that, like, you have to predict how will the users present this to the model
So
beforehand.
this is like when I've got a template in a text file and I don't want to do like normal parsing and I just put like, this is the template underscore underscore underscore.
Yeah.
And that's what the parenthesis is.
Yeah. Well, this might be fun for you to go through because, like, I do it right from here, right? This is just very simple. This is like the first model you would ever learn how to make in data science for transformers. It's just 2 layers. It's a multi-layer perceptron. And we like go down and go down until we're hitting, what is this one? Oh, this is where I added rope embeddings. You can see how does rope multi-mask or mask multi-head attention work. All the way down to like actual llama models. And this is why I said what I said, right? When you get to the llama models, you have these blocks. These blocks serve as the algorithm, right? It is essentially a linked list, and you figure out what each of the nodes in the list are. And once you have these blocks, you'll see down here, we have just an ordered dictionary of llama blocks. And we just spawn number of layers from our config of those. It's just copies just going down. And this is where the like data science happens, is experimenting with what types of blocks do we put in what order, and then we A/B test what makes it better based on amorphous benchmarks that people are kind of gaming anyway. Anyway, yeah, this, I go over this, like when you just train it, all of a sudden you get this crazy loss spike. Why do you do that? So we write a scheduler, and then we do a scheduler, and you see, oh man, it's stable all of a sudden. How did that happen? It's fantastic. I really like this stuff. If you want to dive into this, you can go pretty much as deep as you want. It's
No,
very
I don't.
cool.
It is a rabbit hole.
That is beyond my domain. My domain is up to the point of the HTTP call that sends the pre-constructed, like that list of JSON there, where it's like, this is what this does, this is what that does. Figuring out how to construct that so that I get back a good response, that's where my world is. Once we pass that over to you, I am happy to let you take that.
Cool. Cool, yeah, I think it's really fun, and it informs inference engines and which ones are going to perform better, because I know about how the model performs by itself, and I've written inference engines, so then I get to complain in the Llama C++ GitHub about, hey, you did this wrong because you're a physicist and not a data scientist or whatever.
Can you go back
You're
to
in good
your,
company here.
can you go back to your model list, all your models that are running?
Yeah. Why are we interested in that?
I just want to understand that better. So are these are all running at the same time on your servers or on a single server?
No, so I have two servers. And you'll see denoted by the server name beforehand. We have the Mac, which is the EXO cluster that the Mac serves as the entry point to.
Okay,
And we have this framework desktop, which I think,
okay.
because it's also running Llama C++, we can just go
And some of them
see
said
it.
private and some of them said public.
Yeah, that's based on whether or not I want my kid to be able to just randomly start a job with that model.
Okay. If it's public.
I think it's just on 8080. Yeah. So this is Llama C++. They have a whole server function. This is another one where you can see the logs. One of my favorite things to look at in here.
Wait, you just have this like open to the public?
No, Tailscale.
Oh, that IP address looks like a public IP address.
The 199.
Yeah.
No, it's part of my tailnet.
Oh, wait, is that part of the CGNet or what?
No.
100.64, is that CGNet?
I think it is.
Okay. CGNet.
Oh, it might be.
It's just, there's certain reserve spaces.
Okay.
Yeah,
Oh, we did talk about this.
It's my least, it's the IP range I'm least familiar with.
This is one of the things that I see like almost nobody experiment with, but does a lot to change how your models behave. Because we talked about just now, the model generates logits, and then you have to go through a big old sampling process to get those logits to be useful for someone like you who wants it to write code.
Yeah.
You can change the order of operations of how that sampling happens with anything running Llama C++, including Ollama. And it's fun. It becomes a little bit of art more than science, but you can still do like cool A/B testing for what order do you like for which tasks, right? I generally will put top P above top K when I want like very deterministic coding tasks, when I want to make sure that like, hey, it's not screwing up on tool calls, because this will influence it way more than trying to prompt it into doing better.
What's P and K?
Are you familiar? These are stats terms. So P is like percentile,
Okay,
and K is like the K-armed bandit. Are you familiar with that problem?
no,
Okay, that's fine. They're stats terms.
okay.
So when I am in Claude Code or another harness that is code specific, is it reweighting top P for me? Because it's like,
Yep.
oh, you're in code mode, top P comes first. Oh, you're in chat mode, top N comes first.
Yeah,
Okay.
They-
You're in co-work mode, BOGO sort.
a BOGO sort. Yeah, I doubt that ever happens, but yes, that's exactly how it happens. And with Claude, I think they kind of recently exposed some of these parameters to you to influence in the API. Things like temperature, right? Higher temperature means more randomness in your multinomial sampling, and lower temperature means less randomness. If you put it at 0.0, it turns the model deterministic. Now, whether those deterministic responses are helpful to you is another matter, but it will give the same responses given the same inputs every time, and that's pretty cool.
So is there a difference between setting the temperature to 0 and giving it a random seed and not having the temperature 0? Like, is temperature 0 something that affects every cycle?
Temperature 0 affects the multinomial sampling.
I don't know what that means.
So,
I have not read your book.
Watch 3 Blue, 1 Brown. What's that channel? He does
Yeah.
really good.
3 blue, 1 brown.
3 Blue, 1 Brown. Yeah.
Three
Yeah.
blue, one brown, okay.
He does a really good job explaining like what all the temperature means.
Who is that?
3 Blue, 1 Brown.
Oh, that's the name of the channel.
Yeah, the YouTube channel.
Yeah.
Right.
The more willing it is.
He's fantastic. Thanks for bringing him up. When I was studying this in college, I like lived on his channel for a couple of months to try to figure stuff out.
But, so, what I meant was.
So the temperature comes after the seed. They are both taken into account. If you switch the seed and also switch the temperature, like you get a lot of different things, but you can keep the temperature exactly the same and increment the seed, and you will get deterministic responses for that random seed or any other. Does that make sense?
Yeah, ish. What I'm trying to say is, could I just twiddle the seed myself and not change the temperature and have the same effect? Or is, I'm imagining changing the temperature just has a greater effect in general than,
Then the seed.
changing the seed. I'm
Yeah.
imagining that changing the temperature would cause multiple stages before I get results back to have random twiddles.
Yeah.
Okay.
Yeah, the temperature has a much bigger effect on the seed. I don't usually screw with the seed except for with when I want deterministic responses and I want to save that the model gives this response on this seed when given this input. That doesn't happen super often, but when it does and it's mission critical, that just gets saved and locked down, and we get 0.0 temperature and this seed, and that's saved in a config and we don't touch it. I don't know a whole lot of scenarios where that super applies though.
When you can't be bothered to put it in a text file locally,
Sure, yeah, yeah.
instead you save the seed in a database.
Instead you save the seed. Okay,
All right.
so I've talked for a super long time, and hopefully let's look at these takeaways. Hardware math is knowable, you can develop intuition pretty easily, and that saves you years of studying this stuff, and you can just know what's going on, at least approximately. Yeah, I mean, we talked about the hardware quite a bit. This doesn't really matter, right? I hope that you take this away, but like if you don't, it's not the end of the world.
I got a question
Go ahead.
for non-engineers. So local models will get better over time, right? And maybe the size will be whatever the size is. If you were to say like, you know, if it's a DGX, you know, a couple DGXs, or like buying a Mac Studio, if you were to say, hey, I'm getting rid of all my cloud models, and I'm going strict local, and I have no hardware, what would your kind of go-to setup be for, you know, prosumer, low-level professional, not like H200 kind of stuff?
So I'm gonna give you a frustrating answer here. If you just want to run an inference server, just buy a Mac. It's the simplest. You just run LM Studio on your Mac, and it's gonna be slow. Their token prefill is horrendous. It's like literally 1,000 times slower than the next slowest option. But like It's token prefill. It's pretty fast regardless.
What does token prefill mean?
That's when it's processing your prompt.
Oh, okay.
Macs
Yeah,
are
that's
the slowest.
part. There's an M1 Max with 64 gigs, so I can like load bigger models.
Yeah.
But doing that first, like, I mean, having it think through any prompt, it's like
You have to
minutes.
wait for a minute, and then once it starts generating, it's pretty quick,
Yes.
right? That's
Yeah.
great. That's what I would recommend for like turnkey. I buy it, I download LM Studio, we're good. I don't touch it. For tinkerers, I recommend pretty heavily the AMD Strix Halo. It's a good best of both worlds for like image generation and video generation and also text generation. It's harder to set up. It's not super supported even by AMD, but I think I'll put this up here too. Qzo.
And what does that run for, like, I don't know, 256 gigs?
It is.
Computer died, so.
It'd be about $6,000 to get 256 gigs. This guy made AMD Strix Halo toolboxes. So if you don't want to do the setup, if you are an engineer who loves stuff like Docker, right, you can just download these essentially Docker containers and enter them, and it already has it all configured, right? These are faster than the Mac at token prefill. They're slower than the Mac at generation. You overall get a lot faster with them. They come, I think the biggest one I've seen is 128 gigs in one box, and usually they're soldered, which is unfortunate, but so you can get 2 boxes, get 256 gigs of RAM.
Wait, what is the thing called that I would purchase?
So you would purchase, for example, the Framework desktop, right? And the reason I call it the Strix Halo, you'll see this AMD 395 Max Plus. This is the iGPU, NPU, APU all in one thing that runs that.
So how does that compare to a Spark?
So yeah.
As far as like just pure functionality.
So I did a YouTube video on this, and the production is not super great, but the information is really incredible. It's called I Spent $17,000 on AI hardware, so you don't have to. Where I compare this to a DGX Spark to a Mac Studio. The like TLDR of it is if you don't care about CUDA, the Spark is really not what you want, because that's what makes the Spark very cool and very fun to work with. It's an AI dev platform more than an AI inference platform. That said, if you want to learn about CUDA, the Spark is an excellent AI dev platform, and NVIDIA has created all of they call them NIMs. They've created this whole like example cookbook essentially for you to just copy and paste instructions, and then you can work like that. If all you care about is LLM inference, I probably recommend this over the Spark though. The Spark is way slower at generation. It's the fastest with the prefill because of the CUDA and the Grace Blackwell that's not an actual Blackwell.
And then you can connect to multiple of these.
Yeah.
And this would beat the Mac Studio for image and video channel. So awesome.
Yeah, like
So like that 120 gigs, that just kills me. Like,
But we don't know
It's
that, we don't know
Stone
that
Age.
M5 Ultra yet, right? But
B-Link plus OpenClaw, what the
Well,
hell?
that could be.
Yeah, the new M5 MacBook would seem to be.
Look at this junk. So this is another one of the Strix Halos, but it I don't know if they have their big one. They do right here, the GTR 9 Pro. So you can get this orange branded one, or you can get the one that is like $500 less, that looks more like a Mac Mini. This is the same as the Framework desktop, but with B-Link's like hardware and cooling around it, right? These are the things that I would recommend for like getting a ton of RAM very easily. The reality that a lot of people have to deal with is they already have sunk money into a GPU for like a gaming setup. If you have one of those, I would just say use it, right? You don't need to spend more money to get this working. The hard part of those is figuring out the little art more than science part of how much do I actually offload to my GPU, right? LM Studio has, you literally drag a radial menu for that. Like, it's not hard. That comes from Llama C++, where again, you just drag a radial menu if you don't want to put the arguments into your Llama server command. It's not that bad, but it's a little bit inconvenient and some people don't like that.
Like, so how much RAM would you recommend, like, if, so, like, you were setting people up on
Ooh.
machines to work, or, I mean, I know.
So
there's,
this was in slide 2.
64 gig, right?
Yeah, I mean, so even like for development, coding, stuff like that, you just run.
Doesn't GLM5,
Yeah, I mean, like,
like,
GLM5 is
bigger.
worth running for code, as an agent.
If you are just doing AI for like whatever, you need like 24 gigs. If you are starting to get into like cool stuff, get up to 64, get up to 96, get up to 128. If you're doing this professionally and need it to be always on and need to run like multiple things concurrently, supporting multiple people, we're starting to get up above 200 gigs
Yeah, okay.
Of VRAM.
of RAM plus VRAM.
Okay. GLM 5.1, do you know the set?
I do, yeah, and
I saw that you had it.
It's like 200.
It's like almost 2 terabytes, isn't it?
in full precision, yeah. GLM 5.1 unsloth hugging face. Yeah. So
I
this
paid
is
China $10 a month to use it with my OpenClaw, and it's actually pretty good.
it's actually pretty
It
good.
is pretty solid.
Wait,
Yeah.
who are you paying to use?
China.
So this is GLM 5.1.
No, like,
Z.ai. So there's a Chinese model, like Minimax.
right, but it's still ridiculously expensive, isn't it? I mean,
Now,
like, you
you
couldn't
can get a
use it
$10,
every
you get
day.
a $10 starter plan, and it's, well, I mean, for what you
This
would
is
use it
like-
for, you might run out. 'Cause
So-
I'm not a coder, it's like,
In Q8, this is almost 900 gigs.
right, yeah.
So if you want to run that, you need a bit over a terabyte to fit the model plus the context.
Yeah.
But you can go, like, this is why I talked about quantization before. If you want that to be much more approachable, get the Q4 where you're getting almost the same amount, and it is, what is that, a little over 500 gigabytes. This can fit on a Mac Studio M3 Ultra if you hook it up to like one other device. It can offload the KV cache.
So I guess my question is like, you yourself, what do you find yourself running typically model size?
Usually, so for really fast stuff like that ingestion, when I was creating the LLM wiki, because this is that's one of the reasons that I picked this to show you guys, is if you use Claude right now to create that wiki, you give it like a website, a blog, and it'll generate 25 different MDs for different topics and entities and different sources from that article, right? So I wanted to run it on something a little bit fast, so I did it on Minimax 2.7, M2.7. I like the Minimax models for that. They're about 250 gigs. You can fit it on something with 256 gigs and just like do some context management or quantize your KV cache to make it smaller. And it was able to generate like hundreds and hundreds of articles for that knowledge base. Like I can show it to you in my Termix. It was able to generate, if we look at LLM Wiki, and we actually go into the wiki and like look at sources, it generated all of this in about a day. We can just keep on scrolling and scrolling and scrolling and scrolling. Right, we are well over 1,500 different articles that were generated for this wiki on 256 gigs of RAM, not even VRAM, not even accelerated, in about a day. Part of that is because of the Minimax architecture, the algorithm of going through the model, the different layers that they picked are really nice. But also Minimax is optimized for code. It's not optimized for like creative writing. It didn't really train on that as much. So I used it for this, it went really fast, and it cost me nothing and turned out to something pretty great, right? For most of my coding, I turn towards GLM 5 or 5.1. 5.1 reasons so much, so I tend to stay away from that one unless there's like something really complex. GLM 5 is really great for most things, and I get about 35 tokens per second on it, and that's good enough for me, you know. For
What's the most important piece of hardware for that? Is that on the Mac Studio, or is that on the RTX? Or?
that's spread, so it's in the EXO cluster. So a lot of it is on the Mac Studio. It does its token prefill on the Spark because the Spark is quick, and then it does the actual model generation on the Mac Studio.
Okay, and sorry, again, what is the Spark? That was the Halo, or
That's the DGX Spark. That's the NVIDIA machine.
Oh,
It's another little box, kind of.
oh,
So you're taking tokenized in RAM context and shipping it over the network,
To the Mac.
and it's still so much faster than the Mac.
It is so much faster. Yeah.
you said Spark DGX. How much is one of those?
So they were $4,000 when they came out. They're probably over 5,000 now. I don't know.
Oh, okay, so this is like affordable.
Yeah.
Like I could buy one of these and put it on my credit card.
Yeah.
Okay.
What do you use cloud model? You mentioned you use cloud models for some
I
things.
use cloud models for work because my work asks me to use them. I'm assuming that's kind of an investor's thing, that if they can show a certain amount of usage per developer, they get more money.
But say there was no compulsion, would you ever turn to a cloud model over a local model for any reason whatsoever?
I don't get any benefit from them, right? I have spent years and years and years building systems for my local models to work. So when I go use Claude Code, I feel like I've been cut off at the knees because I don't have all of my middleware. I don't have all of my tools already integrated into it, especially because a lot of those I was building as the tools were coming out, and I have tech debt associated with how they're called and how they're formatted. And my open code has kept up with all of this, and my Crush has kept up with all of this, but Claude Code, I don't have that, and so it gives me subpar responses and uses way too many tokens to get them. That's frustrating for me. That is like I recognize that's a me problem, right? That's not the experience that most people have with these. And so like, I don't want anybody to feel like this is something you just jump into. I built this over 6 years, right? Go ahead.
That's what I was gonna say, is like for most of it, so, I've said this a couple times in conversations with you.
Yeah, to me.
You're not a dev,
I'm not.
and that's not your goal, it's not what he's trying to do, he's not trying to like software engineer all day long. He's got a lot of code going on, like he's not like bad, or just like, that's not his
It's
focus
different,
or his understanding. What he's conveying here is super important because it is the future of our industry, but it is also not a weekend project. It is a journey. And you should probably start approaching it by layers and like fiddle, not invest several $1,000s in a machine, just use whatever's there. It will be slow as all get, it's totally fine. Run it on a Raspberry Pi, you can.
Yeah.
And
I made YouTube videos about it.
But it is very important that like these tools work certain ways, and they are not the magic black boxes that the industry and especially leadership want them to be. And being able to speak to the actual details and be able to manipulate these over time is going to position you a lot better for when the bubble bursts and we're all left with whatever is happening, and being able to shift and
Can you
Well-
define that? What is the bubble bursting?
the AI bubble. Whatever the size of that bubble, we're in a bubble. It's an AI bubble. It's a.
Can I offer a practical explanation?
Yeah.
$200 a month for a Claude Code subscription. Used to last the whole week, now runs out after half the week.
Yeah.
They gave me $200 free as extra credit. That ran out in 3 hours.
So token efficiency, just
No, like, it's all a lie. Like,
it's just not. Yeah.
like they're
moment
spending,
the moment VCs are no longer funding our toying around with their vision,
it all goes away.
we will be paying our entire salaries a month for the
So
things
they
we're
get you
doing.
It's all
It's okay.
subsidized right
No,
now.
it's not just they get you hooked, like it's fake, like they're lying, it's a Ponzi scheme. Like it's, they are giving me tens of thousands of dollars of GPU for $200 a month.
Yeah. It doesn't make sense.
It's not feasible.
Yeah.
So
Yet.
unless a miracle happens, which it may, because it happens all the time in our space where things.
Is that what they're
literally
betting on?
get
Is
fast.
there not like a benign explanation? Like maybe they're betting on some sort of architecture.
Okay, but like in the same way. that
Integer
people-
instead of floating point, like something's
Yes.
gonna make.
Yes.
You know.
Yes, but it's like a prayer, right? It's like remember WeWork or you know any of these other giant like that's what they're doing. They're taking all the investor money and they're spending it without having any clear plan of how this could ever be profitable. I mean, am I wrong?
No. I've
Very
been,
specifically, like to your point, that's what this is about. Is like you can run these models on your cell phone. We've been doing that for years now, and they can be pretty dang good, if not just as good as some of the frontier models, if you know
What you
how
want.
to work.
well, specifically if you know what you want, right? The state of the art right now for data extraction is less than 4 billion parameters because you don't need that much. The reason these models are giant is to account for all of the things that people are going to ask them instead of just focusing on one task and getting really good at it.